it that we are doing today? Prior to us looking at what we are doing today, I want us to have a look at the activity that we gave you yesterday. That activity, ladies and gentlemen, we have an activity each and every day at the end of the lesson that is meant to simply test your understanding of what has been done so that we can see if we need to revisit a certain lesson. So these are the questions that were there. I have tried to highlight as well as color the answers. They are underlined. So ladies and gentlemen, the first part is the true or false part. In the true or false part, we said 1A, pulling forces is known as compression. Ladies and gentlemen, is that true or is that false? I just want to have a look at the chat box so that I can see how people responded to that. So pulling forces is known as, what is this? Pulling forces is known as a compression example of a force. Is that true or false? Well done, how? That is actually false, all right? Number 1B, we said tie beams are horizontal beams. Is that the case? Again, let us have a response there. Is that true or is that false? Ladies and gentlemen, the answer there is absolutely true. So number 1A, pulling force is known as compression. That is false because a pulling force, ladies and gentlemen, is what we call tension force because you're pulling in opposite directions. Now, if you are pulling things in opposite directions, the name of that force is not compression, it is actually tension force. All right, number 1B, we were saying tie beams are horizontal. Is that true? Is that false? Ladies and gentlemen, that is actually true. I hope you all got that correct. We then go to question number 2, which said, or rather requested you to give one word for the following descriptions. Number 2A, pushing force. What is that? When things are pushed against each other, what is the answer for that? Ladies and gentlemen, a pushing force is in fact a compression force. It is not tension force. I seem to have made an error there. Please forgive me. So when things are being pushed against each other, remember they are coming in the same direction. As a result, it therefore becomes this type of force. It is not tension force. I made a mistake there. Please, my apologies once more. All right, let's go to number 2B, a diagonal rod or bar. Remember we said a diagonal rod or bar is something that is very strong. An example of that we said is a member. The name of that is called a strut. All right, so number 2A, a pushing force, ladies and gentlemen, is not tension force, it's compression. Number 2B, a diagonal rod or bar, that is actually a strut. I hope we all understand. Let us go to number 3. We are asking you to give 2 important characteristics that we need to be mindful of when we want to stabilize our cell phone towers. All right, the first thing, ladies and gentlemen, is when we have to focus on the bar. So what are we saying? The base of your cell phone tower needs to be wide, meaning that you achieved triangulation. The shape of your cell phone tower is a triangular shape because triangles are actually one of the strongest shapes in terms of stability. That is number 1. Number 2 is that the base of that, the foundation, ladies and gentlemen, needs to be wide. Yesterday, I remember someone gave us a great example and they said, when they are having karate, karate competitions, they are told by their teachers that they need to widen their legs. That means they need to open up their legs, therefore achieving stability. Even here, when we speak about the cell phone tower, remember I said you're going to be doing the cell phone tower in the, what is this? Thank you so much, Tiana. I am glad that I also noticed that. Thank you so much. All right. So, yeah, so in your karate competitions, for those of us that may be involved in that, you find that your legs are supposed to be widened and therefore you achieve a certain amount of stability. That is number 3A. Number 3B, another thing that we have to do is to create triangulation. Ladies and gentlemen, that is what we are going to be talking about today, the strengthening of structures. And we are going to speak largely about triangulation. And yes, if you are guessing, triangulation comes from the word triangle. I want to access the chat box. I am aware that when I open it up, there are certain blocks that appear on your screen. I will remove those blocks after I've read some of the lessons. All right, the blocks. Okay, people are complaining about those blocks. Okay, all right. So what is the previous lessons focus? What were we speaking about? Number 1, remember I said we are going to introduce this part of our lessons and we are doing that so that we can be able to form a foundation, so that when we move on to something else, we revise what we did yesterday, so that when we continue, we are all on the same page. But also for those people that were unable to attend yesterday's lesson, they can be able to get some information. And of course, maybe they were not able to go onto our African Team Geeks YouTube channel. Therefore, this will also assist them. So yesterday, what were we doing? The first thing, we spoke about attention force, and I said, ladies and gentlemen, attention force is when things are pulled on different directions, and therefore things are being stretched. And that is what you are doing. I am making this as an example. Maybe someone is pulling a rope on this direction on the right, then someone else is pulling it on the left. That is an example of attention force. So ladies and gentlemen, that's the first thing. Then we go to the second type of force, compression force. Now, compression force is when you push something. Now you are doing this, it means that things are coming together, they are being attached to each other. As a result, when you compress things, they become smaller. So tension force is when you are pulling things in different directions, you are going that way and that way. Compression force is when things are coming in the same or similar direction. We then spoke about two parts that are important in a cell phone tower. We spoke about a tie beam as well as a strut. Ladies and gentlemen, we said a tie beam is horizontal. I said to you, horizontal is when something is leveled from left to right or from right to left in a crisscross position. Therefore, it supports whatever load. And as a result, it supports it by pulling it together because there are crisscross that are being formed in our cell phone tower. We are going to investigate this extensively today. All right, we then go to the last part of our activity that we did yesterday. We spoke about struts, and we said the struts are diagonal. So they are found on the two sides of the cell phone tower. They are slanted. What does that mean? It means that they are skewed. They are not straight. What are they doing? They are actually supporting the tie beams that are found inside, which are crisscross. Again, I repeat, struts are found on the two opposite directions of our tower, very large, very big. What are they doing? They are supporting the inside of the tie beams that are found. So this is what we did yesterday, ladies and gentlemen. So today, what is it that we are focusing on today? What are we doing today? All right, so today, I said yesterday, we are looking at the strengthening of structures. That is number one. Number two, we are looking at triangulation. And number three, we are looking at structural elements. So again, I repeat, ladies and gentlemen, we are looking at strengthening structures, number one. Number two, we are looking at triangulation. And number three, we are looking at structural elements. I hope you understand. I hope all of us are excited. Please allow me to just have a look at the chat box again. Okay, theory, is it maybe because I just opened the chat box? Is that maybe why the block is showing again? Ladies and gentlemen, please excuse me. I am trying to make sure that we are all on the same page. So yes, maybe please just text me on WhatsApp, theory, and then so that I can see, because I had removed it before, but I just opened it up now so that I can be able to see what is happening on the chat box. And maybe you can also just write to me privately so that we can be able to see what it is that we are doing. Ranzu is asking for a copy. Ranzu, remember what I said. On the African Team Geeks website, you will find a PDF copy of these lessons so that you can be able to go through them at the comfort of your own home, number one. Number two, you can, of course, go to the African Team Geeks YouTube channel and you can be able to see them. All right. Okay, guys, let me try and sort out the slides issue because I can see that it's the problem. Okay, let me try and fix that theory. Yeah, let me see if I can fix that there are no blocks. My apologies, guys. I see that we are sitting on 37 participants. Thank you so much. That is truly appreciated. Let me try and do that. Okay. Okay, guys, again, I apologize. I am simply speaking to Theari so that I understand what she's saying on the other end. I apologize for the inconvenience. Okay. this is what we are looking at today. I repeat, strengthening structures, triangulation number 2, and structural elements. Thank you so much for your patience, and thank you for being here again. All right, let us continue. I seem to have wasted some of your time. So I want us to continue by thinking about the following questions. The first question is, what is a known common shape of a cell phone tower? Ladies and gentlemen, I think already in our minds, we should be thinking about the triangular shape, because that is what we've been talking about throughout the lesson, that triangulation is one of the strongest shapes. So that is what we are doing, number 1. So what is a common shape of a cell phone tower, number 1? Number 2, how do rugby players, and I'd like to extend that question also and include martial arts or karate activities. How is it that they stance their legs when they want to not be pushed against each other by other opponents or members? And already the answer for that should be similar to the question in number 1. So question number 3, ladies and gentlemen, how do you make a structure stable or strong? Remember, the purpose of this lesson is to prepare us for the cell phone tower that we are supposed to do out of 70 marks, the PET for term 2. So all of these aspects are important so that when we do our PET, we can be able to tick off that criteria where it speaks about stability or how strong the actual model is. So ladies and gentlemen, let us start with triangulation. Remember, we are speaking about strengthening structures. I had advised in previous activities that may you please have a pen on the side with a paper or a scribbler, so that when we are speaking, you are therefore taking notes or you are drawing, so that you can be able to remember for exam and test situations. So the first example of strengthening structures that I want to speak about is triangulation. So what is triangulation? Remember, I said triangulation, that word comes from the word triangle. Ladies and gentlemen, triangle, the three-cornered shape, if you may. So what are we doing when we are triangulating? We are actually arranging members. Remember, I said members are our struts. They are found inside the cell phone tower itself, in the case of a cell phone tower, of course. So we are arranging these members in triangular shapes to make frame structures strong. So triangulation, ladies and gentlemen, is actually limited only to frame structures. We are strengthening frame structures in this regard, the cell phone towers. So let's have a look at these two examples. The first structure here is an example of a weak square frame. So now if you squash that frame square, which means that you are actually compressing it. Remember, I said compression, a force is when you're pushing things against each other. So now if you compress the two sides of this square frame, you will find that it will be easier for it to break or for it to actually just topple over, and you will have another shape changing from the square. However, if you add a member, as it's been done here, a member being what we call a cross piece, you will have a situation where if you push the force, you try to compress this square frame, you will find that this member will then introduce an opposite almost force so that it stops it from being squashed altogether. So introduction of this cross piece will assist you to strengthen a frame structure such as this. Ladies and gentlemen, so you can see from this square frame, if you introduce a cross piece, you then have what we call a triangular shape. So you have triangulated this frame shape. So you've got 1, 2 triangular shapes, which means that you've strengthened the structure. If you want, you can introduce another cross piece that will come across these areas where I'm moving the cursor. Then you have further triangulated or strengthened that shape. So number 1, a very weak structure because there's nothing inside, there are no members. If you push it against each other or you compress it, it is easy for it to break. However, on the second one, you introduce a cross piece or a member, and as a result, it becomes very difficult for you to actually break that shape. Ladies and gentlemen, I hope you understand. We go to the second example of strengthening structures. The second example that I want us to speak about is what we call pylons. So what are pylons? When we are driving, mainly in a lot of instances, we are driving to, say you're driving to Kimberley, you're driving to Cape Town, you're driving to KZN, or of course our nearby neighboring countries, your Mozambique, your Swaziland. You will find that in the remote areas, what does the word remote mean? It means that where there are no houses and malls, wherein people are not living, you will find structures that look like these. These structures, ladies and gentlemen, are called pylons. What is the use of these pylons? The pylons are used so that they can be able to stabilize very heavy objects. So these are our pylons. Like I'm saying that on the sides of the roads, if we are taking a road trip with family or friends, we find these on the sides of the remote areas or on the roads. What do? They are meant to hold or carry very strong, heavy objects. What are these objects that are being carried? Like these electrical wires, which are coming from power stations. You can imagine, ladies and gentlemen, if it's coming from a power station, it is actually transferring electricity to different homes, different houses, to malls, to factories, etc. And as a result, it's going to be very, very heavy. It is not going to be like a wire, for example, this one that I use to charge my device. It is going to be very heavy, and therefore it needs a very strong structure so that it can be able to hold those. And those are called pylons. I hope we understand. Let's look at the third and last example of strengthening structures. Those are what we call mine head gears. Ladies and gentlemen, I've said this even in natural sciences. If you look at certain weights, you find that they are a combination of two weights. If you break those two weights, you'll be able to understand what the concept is or what that weight is. So mine, obviously, it's happening underground. We are digging for gold. We are digging for coal, minerals, etc. Headgear, it means that it's at the top of something because this is the head. So already you're having an idea when they're speaking about mine headgear. It has to do with the mine. However, it is at the head, meaning that it's at the top of something. Let us look at the definition so that we can see if we've got that correct. So what are mine headgears? These are tall frame structures that are built on top, again, which goes to the head, on top of mine shafts to hold machines that transport people and equipment inside the mine itself. So it means that here, all the equipment will be coming. As I'm moving the cursor, they are going to be making their way inside the mine itself. So this is a mine headgear. It's at the top of the mine. The mine is obviously underground. That's where we get our coals and all those precious metals that we sell so that we can make necklaces and rings, etc. So you find that the equipment that is needed for the miners inside the mine itself is going to make its way through here, and it's going to go all the way down so that it can be able to assist our miners on the ground. So again, ladies and gentlemen, we've got three types of strengthening that we spoke about. We spoke about the triangulation, which is simply the addition of a member in a frame structure so that you can be able to strengthen it. Then we spoke about pylons, which are used to carry large, heavy objects. These are important for electrical supply into our homes from power station. The third one is mine head gears. Ladies and gentlemen, I hope we understand. So let's go back to the cell phone tower itself. Remember, the cell phone tower is most important. For what reason? It's most important because this is what we are doing. Again, I emphasize on the third term, actually the cell phone tower is done each and every term. We are doing it so that we can be able to get those 70 marks. So let's investigate this cell phone tower to understand the reinforcement techniques or the structural elements of how this has happened. So at the top, the weight of the tower is pulled down by the force of gravity. What is the force of gravity? A teacher taught me this in my physical sciences class long time ago in my grade 10 class. Force of gravity is basically the concept that everything that goes up must come down. So if you throw something up, it must come down. So it means that everything is being pulled down by the force of gravity. And that is the case with the top of the cell phone tower. And then we've got what we call columns. Ladies and gentlemen, I have done my best so that I can be able to point you to the columns. So these are the columns. I hope you can see that red arrow there. So inside there, these are our columns. What do columns do and what are they? Columns are vertical structures that hold the weight of the structure above. So this is our column that is found inside our cell phone tower. What is it doing? It's holding the weight of the tower itself from above. That is what it's doing. And then we've got what we call guys. What are guys, ladies and gentlemen? Guys are the cables on the sides of cell phone towers. Let me emphasize this. There are cell phone towers that do not have guys. Why is that? Because their bases are usually wide. What is the base? The bottom of the cell phone tower itself. And if the base is wide, it means the cell phone tower is stable. But if the cell phone tower is linear, we therefore add guys so that that cell phone tower can be anchored onto the ground. So these are not usually found in a lot of cell phone towers, but in some you might see or you might find them. But guys are simply the cables that anchor. What is to anchor is to hold or to ground something so that something creates stability. So we've learned two important parts of a cell phone tower today. The columns, which are found inside the tower itself, they hold the weight of the structure of the tower. So the entire structure is held by the columns. These are the columns inside. I've highlighted that in red and pointed to each directly. We then have the cables. The cables are on the side. They anchor the cell phone tower to the ground itself. I want to play you a video that speaks a lot about this so that you can understand the differences between the strut as well as the columns. We are currently sitting on, what is this, 42 participants. Thank you so much, ladies and gentlemen. I'm really hoping that the audio is not going to disappoint because usually that's what it does. Let me just open the chat. I'm sorry there'll be a black spot on the side. I really, really apologize, but I want to have a bit of interaction with you. Otherwise, the lesson becomes absolutely boring. Okay. All right. So let me just try to open that up.
Mechanical AI. Did you know that ancient Egyptian architecture, as early as 2600 BC, made use of columns to support their roofs, and that monoplanes make use of struts to attach engines and other loads? This makes us wonder, what are columns and struts? Before we jump in, check out the previous part of the series to learn about what cylindrical and spherical shells are. Now, columns are short, thick structural members which are subjected to compressive forces, bending moments, and shear forces. They are the main supports in a building or structure. They usually fail by crushing when the yield stress of the material in compression is exceeded. Struts, on the other hand, are long, slender structural members in an assembly, which are subjected only to axial compressive forces. They fail by buckling sometime before the yield stress in compression is reached. As the name suggests, the minimum load at which buckling occurs is called buckling load. At values of load below the buckling load, a strut will be in stable equilibrium, where the displacement caused by any lateral disturbance will be totally recovered when the disturbance is removed. At the buckling load, the strut is said to be in a state of neutral equilibrium, moving beyond which it simply buckles. Types of end conditions for a column are the major factors which influence the load-bearing capacity of a column. They are of four types. First, column with both ends hinged. This is a standard column end condition. As a side note, effective length of a column is defined as the distance between points of zero moment. Effective length in this condition is equal to the length of column. Second, column with both ends fixed. This is the strongest column end condition. Both ends fixed column carries maximum load, and effective length for this condition is considered as half of total column length. Third, one end fixed and other end hinged. In this condition, one end of a column is stronger while the other end is very weak. Equivalent length for this end is 1 upon root 2. Fourth and the last condition, one end fixed and the other end free. This end condition makes column to bear the smallest load than all other end conditions. Column in such a condition is very weak. Equivalent length for this condition is 2L. Hence, we first saw what columns and struts are, and then went on to find out what the types of end conditions for columns are. So like, subscribe.
All right, guys, thank you so much. I really, really hope that video assisted you so that it can explain columns and struts in more detail for all of us to be able to understand and of course continue with our lesson. All right, so I just want to have a look at the chat box so that I can respond to some of the things that are flashing there, because obviously it means that there are some questions or there are some comments that people have. So I just want to have a look at that. Okay, where is it? Yes, there we are. Okay, I can hear. Thank you so much, Khau. Thank you, Jackie. I also think it's a great video. Tiana is asking a question. The cell phone tower wires, if you follow them, you will find your way to your place. No, 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 no. No, you will not. Remember cell phone towers, I made an example. I said that cell phone towers, Tiana, are usually found, for example, in our schoolyards. So the cell phone towers are there obviously to give you network. So we are just speaking about the technical uses or importances of cell phone towers. So they give you network, obviously satellite, data coverage, etc. They will not assist you in finding your way to your place because they are not situated or found to your place. And by place, I'm assuming that you're speaking about your home. All right, so let's continue with our PowerPoint lesson or presentation. We are sitting on 43 participants. Ladies and gentlemen, thank you so much for telling your friends about us. And I really appreciate that there's been no vulgar or no swearing. All of us are participating and all of us are listening quietly. As I said, I really, really hope that you have a pen and you've got a book on the side wherein you are writing some of the important aspects of this lesson. All right. So what did we speak about today, ladies and gentlemen? Today we spoke about triangulation, and we said triangulation is putting members so that they form a triangular shape. We made an example. I am going back to the slide so that people can understand of a square frame, which is weak because if you squash or you put or you press or compress the two parts of it in the same direction, it will actually break that square. However, if you add a cross piece, you will find that that square will become strengthened. So that is what triangulation is. And then the second part, we spoke about pylons. We said these are tall frame structures that carry or hold heavy loads. So this is an example of a pylon. The heavy loads that are being carried there are the wires that are coming from power stations, which have a lot of current, and therefore they are really, really large. They cannot just be carried by anything. Hence, the pylons are important in that regard. The third thing that we spoke about is the mine head gears. We said those are tall frame structures that are built on top of mines. This is an example. There's a mine underground. These are our mine head gears. These are used why? So that the equipment that is supposed or needed by the mine workers can make its way all the way up to the mine head gear and go down. It's a mine head gear because it's at the top of the mine, as the head is at the top of the body, for example. Then we spoke about reinforcing techniques. We spoke about columns, and we said those are like beams. And this is what we are speaking about. These are our columns. We also spoke about guys. We said those anchor or they create stability for a cell phone tower, particularly a cell phone tower that does not have a wide base. What is a wide base? Is when the cell phone tower has triangulated that the bottom of the cell phone tower, the two struts are actually open and are apart to a point where there is stability. So now if it is a linear cell phone tower, as you might see some of them, many are actually anchored using guys, which are also cables. Ladies and gentlemen, there is a video also that I want us to play. I see we have a couple of minutes remaining that also simply summarizes the cell phone tower strengthening aspects as well. Let us play that video. I hope this is assisting you, and I hope that you're already imagining how you are going to do your cell phone tower.
This video demonstrates
Our solution consisted of the following steps. 1. 14 feet with 4.25 meters deep holes with a diameter of 1.25 inch.
Such deep drilling is not common in all repairs, but it was required at this specific site. 2. One layer of quake wrap unidirectional carbon fabric saturated with quake bond epoxy was bonded in vertical bands to the entire height of the tower. 3. A second layer of the same carbon fabric was applied to the lower 2/3 of the tower height. 4. The entire height of the tower was then wrapped with resin-saturated glass fabric in horizontal bands. 5. Pylometic jacket was used to create a reinforcing shell around the lower 4 feet, or 1.2 meters, height of the tower encasing the steel reinforcing bars. The 6-inch, or 150 millimeter annular space was filled with an expansive non-shrink grout. 6. Several pylometic jackets were used to create a shell with an annular space of 1.5 inches, or 38 millimeters, from the height of 4 feet, or 1.2 meters, to a height of 16 feet, or 4.9 meters. This region was also filled with an expansive non-shrink grout. 7. As part of this repair, a number of existing cables and conduits that were attached to the tower were carefully moved slightly to accommodate the repairs. This did not require disconnecting any of these cables, allowing the tower to remain fully in service during the repair. These appurtenances were later pushed back to their original location. Field installation of this project was completed by FR.
Right, I'm going to stop the video there so that we can move on to the slide. I see that we have only but a few minutes remaining. All right, but that video basically is speaking largely about the reinforcing techniques that we spoke about, the introduction of columns, and of course, the introduction of guys or cables on the side of the towers themselves. Ladies and gentlemen, this is our activity, very simple and very straightforward. Question number 1, apply triangulation or reinforcement for the following. So you've got 2 shapes there, which are blank. I would like you to use your understanding of triangulation that we've been speaking about so that you can strengthen these. So go crazy here, use everything that we have learned so that you can be able to strengthen these 2 examples of shapes. Interestingly enough, this is already a triangle, but it should be interesting to see how are people going to apply triangulation here. Remember, when you apply triangulation, you arrange the members in a way that creates a triangle. So whatever it is that you do to this shape, whatever you add here or here must maintain or it must make a triangular shape, which is a form of reinforcement or the strengthening of structures. So use your own understanding, discretion. Like I said, go crazy so that we see that you understand. Question number 2, use your own knowledge, ladies and gentlemen, so that you speak about the types of forces for the following. So struts. We spoke about struts and we spoke about beams as well as guys. When we speak about all of these, please speak about the types of forces. The struts, are they useful for compression or tension force? Remember, compression is the pushing force, tension is the pulling force. So struts, how do we use struts? Why are they important in a cell phone tower? Type beams, same question again. Do we use them for compression or tension? Remember, all of these are simply meant to reinforce or to stabilize the cell phone tower itself, as well as guys. So I'll leave that there for about 2 minutes so that you can be able to have a look and respond. All right. Yeah, welcome, Kia. Thank you so much if you enjoyed the video. It really, really means a lot to me. All right, Jackie is asking if we must play the video. Now, Jackie, because of the time limitations, we cannot, our period is ending soon. We will have to play it tomorrow. Sorry about that. So we'll play tomorrow. Remember, tomorrow we are speaking about the making of the cell phone tower itself. So that's what we are talking about tomorrow. Tiana, thank you so much. I always enjoy your interactions and your additions. So thank you so much for saying that you enjoyed the lesson. It meant a lot to me. I really, really appreciate your questions and all your additions. Pando, thank you so much for joining us. It's a pleasure to meet you. I've never seen you here before. Please make it a habit to always join us, Pando, each and every day at 12 in the afternoon. Mushuri, I apologize for that. I just try my best to read as many messages as I can. I can never ignore you, Mushuri. Each and everyone that is here is important. Mushuri, thank you so much. I really, really appreciate your presence here today. Sarai, also thank you. Sarai is also here. How, thank you so much for saying this was a great lesson. I also think it was a very nice lesson, regardless of the hiccups and disturbances here and there. Guys, thank you so much for your maturity and for understanding, and also for not swearing. Thank you so much, Mushuri. Ranzu, thank you so much as well. Guys, I hope we've taken a screenshot of this. If we have not, remember, you can access this lesson on YouTube, on African Teen Geeks YouTube channel, of course, so that you can be able to watch this video again, or go to the website to access this entire PowerPoint presentation, and you can, of course, download it there. Ladies and gentlemen, these are our links for the preparation of this lesson. Remember, I said this is very important, www.ukuqonda.org.za. This is an entire book from term 1 to term 4. It actually is KEBS compliant. It is made by our great sponsor, the Sasol Foundation, so that you can be able to study everything in technology. I would advise download this book. It is very, very helpful. Of course, these are just some of the links, including the videos that we played. So what are we doing tomorrow? Tomorrow we are evaluating cell phone systems. Remember, I said we are speaking about making the cell phone tower, but before making the cell phone tower, we will evaluate cell phone systems. I would be interested in finding out if you guys understand what cell phone systems are thus far. But if you don't know, don't worry, that is the purpose of tomorrow's lesson. Ladies and gentlemen, you can find me on Facebook at Shanti Songo with an X, at African Teen Geeks. That is our official website handle everywhere on all social media platforms, at Izora, at DBE_SA, of course at Sasol SA. Remember to hashtag Sasol Foundation, hashtag STEM Champions, as well as hashtag Lockdown is School. Ladies and gentlemen, thank you so much for being here. I cannot wait to see you guys tomorrow. Enjoy the rest of your day and the lesson that is coming after that.